Hi, I'm Ross Duran, and I just want to do a quick film of this demo I did today, mainly to share with some fellow teachers, but thought I'd put it out there. So it's just set up the way it was in my room. I haven't honestly scripted this out that much, but here's a demo I did with my students about spectrum analysis and using some gas tubes. So the supplies are a few gas tubes, and I used a diffraction grating for them to look through when we did it. And I've got in this box, I've got my apparatus for making the tubes glow. I just put a cardboard box around it to make it a bit darker because it's hard to get in my room dark. So inside the tubes are clear glass like this. They are filled with certain gases. This particular one has krypton in it. In the ends, those are electrodes so that you can pass electricity when you put it in the machine and run electricity through. When you run the electricity through this gas, it'll cause the electrons to jump energy state to energy state, and when they do that, they'll end up emitting light on their way down. And since each element or compound has a different electron configuration, they'll make different kinds of lights. So the first tube I've got in there is actually neon, just because I think we're all sort of familiar with the concept of a neon light. Neon lights aren't painted red. They are clear glass tube like this one, but when you electrify them, the neon glows a bright red like that. So what you've got in there is just one of those tubes, just like the one that I showed you, and but the electricity is flowing through, making the electrons jump around there, emitting light. But using a diffraction grating, we can see why this light is red and not white. White light, as you probably know, is made of all the colors of the spectrum, so red light must not be. And if we use this diffraction grating, it bends the light like a prism. So over there, you can see, there it is. That's the part of the rainbow that neon is made of. There's very discrete lines, a lot of reds, oranges, and yellows. Notice it's not every color. There's not much green and blue. That's why this appears red. The reason there's lots of individual lines is each line there represents one way an electron can jump around inside the neon atom. So that's what we call the spectrum for neon. It's like a fingerprint. If you electrify neon gas, it makes those lines when you looked at it through a prism. But this one's pretty complex. Let's look at something simpler. I'm going to talk while I move these things. So what I'm going to replace it with right now is hydrogen. Why hydrogen? Well, a couple of reasons. For one thing, it's the most abundant gas in the known universe, and that makes it useful because what we're doing this for is so that we can study more about stars and light and the Big Bang and understanding how we know those things when all we have from the stars is light. But also, it's going to be useful because it's a very simple element compared to neon. So here goes hydrogen. So that's hydrogen gas. It's glowing. First thing you notice is it's a different color. It's not bright red. It's purplish. Why is that? Well, let's find out. Using this diffraction grating, we can see what colors that's made of. Ooh, there it is. So what you'll see is a very bright red line, a very bright turquoise line, and a purple line. There's an even deeper purple line that I'm not managing to resolve with this equipment. There's 4 main lines in hydrogen. So one thing you notice is it's much simpler than the neon was. Why? Well, hydrogen's the simplest element there is. It has only one electron, so there's a lot less ways for the electron to be jumping around on that atom. This is interesting because when we look at stars and we collect their light through a telescope and stick it through a prism, we see a lot of this fingerprint. That's how we know that the stars are made of hydrogen. This will also be a really important one when we start talking about the red shift and blue shift in Doppler in another lesson. So that's what hydrogen looks like. That's the fingerprint. We see it in the stars. We know they're made of hydrogen. The next thing we're going to look at will be helium. Why? Well, because what stars are doing is taking this hydrogen and turning it into helium over their lifetime. So when we look at stars, we see these 2 main fingerprints. If it's a very young star, it has a lot of hydrogen. If it's a very old star, it has a lot of helium. And we see 2 distinctly different fingerprints for those 2 things. Right away you can tell that's a different color, right? That is not the same color as the hydrogen was. Let's take a look at its fingerprint when we send it through this diffraction grating. Whoa, a lot different. There's still a red line and a turquoise line, but look at that really bright orangish yellow line. When we take starlight and we look at it through a telescope and send it through a prism, if we see that bright yellow line, we know there's a lot of helium in that star. That means it's older. because the hydrogen has been turning to helium inside that star over its lifetime. The red line, by the way, is not in the same place. If you could compare it, it's a slightly different red line. There's some turquoise and some purple there. Helium's still a pretty simple atom. It only has 2 electrons, so there's not lots and lots of lines like neon had, but it's got a very distinctively different fingerprint. Over the lifetime of the star, we see the lines fade in and out. A young star has very bright hydrogen lines, and over its lifetime it'll slowly get dim helium lines until they take over the brightness, and this is what we see. Of course, in very old stars, other elements begin to get made too, so things get a bit more complex. But anyway, there's an introduction to these spectrums and the fingerprints that they make, and how it is that astronomers can collect light and use them to know what the stars are made of. Thank you for watching.